when you're doing hack the box, or if you're on a real engagement and you get back a reverse shell, that is the best feeling. So what's the first thing you do after you get back that reverse shell? For me, it's a shell upgrade. I want to have my up arrow to get to previous commands. I want to be able to tab complete out long folders and commands. I want to be able to interact with SU and other commands like that. If I run something like it's stuck in a loop, I want to be able to control C and get out of there. So, whether you're going to use the TTY library inside of Python, or maybe you use the script command, you're going to do something to get you a TTY. And after that, you're going to background it and you're going to run stty raw minus echo, and then your foreground. What is all of that doing? If you're anything like me, you've been using these commands for years and you don't really know what's going on under the hood. That's what we're going to change today. This is OXDF, and today we're going to be diving in on TTYs and shell upgrades. It should be super interesting, so stick around and I hope you enjoy it. So what is a TTY? What is a PTY? This actually goes back to 1869, and they've got the stock ticker coming out now, and people want to have stock prices in real time. And so their computer receives these prices and they want to print them onto these devices called teletypes. And teletype is what TTY is short for. This teletype thing is printing out a strip of paper, it's getting stock prices, it's printing them. And so the TTY subsystem in Linux is born, where it's going to manage things like, hey, I just got this mess of characters in, I need to print it to this strip of paper. I need to know, oh, the paper can only hold this many characters before I need to add a new line and go to the next line. I need to know the baud rate that I talk to this hardware device on. And so these kinds of things start getting programmed in and configured so that the subsystem can manage to talk to different teletype devices in kind of configurable way, and different devices can specify, this is my baud rate, this is how many characters, etc. These things are basically non-existent anymore, but the pseudo terminal, the pseudo teletype, the PTY comes around, and it's basically the same subsystem now controls how output gets put to your terminal. It has the same kind of issues, right? You need to know, oh, I can put this many characters before I need to wrap around to the next line. You also start to see things like control characters come in. So what happens when I hit Control C? So let's go ahead and actually take a look at some of this. We'll go over here to VM, and there's the TTY command. And so we can actually just run that, and we can see this is the physical device that is associated with the TTY that is associated with this, what's going on in this window. If I open up a new window, see, and I TTY in this one, now I've got a new device. It's dev PTS1. I had 0 over here. I can do this, we could do this a few more times, see that we keep getting more. So that's kind of cool. We can also use, let's see, we use stty minus a, it'll show us all the configuration associated with this TTY. So the baud rate doesn't make a lot of sense, but this window has 30 rows going top to bottom, 120 columns. It's got all of this stuff here where these are different, defining different key combinations and what they do, and we'll dive on that in a minute. Then we have all these different characteristics, and you can see every one of them exists, and it either has a minus in front of it or it doesn't. And so the minus in front of it just basically means don't par odd, and the not, in this case, it is echoing. It is echo-e. So what are all these things? We can do man stty, and we can say, so, what was it, PARODD? So sets odd parity. Not exactly sure what that does, but at the end of the day, in this case, my TTY is not par odd. If we look at echo, that's an interesting one. Echo the input characters. So as I type, do I want the input characters coming back out? The answer to that, actually, yeah, usually you do. We will actually mess with that in a little bit. We'll look at why. We can also do some things. So for example, this interrupt is set to, right now, effectively Control C. So that's what happens when I start echo, hello. And if I hit enter here, it runs. But if I start typing this here and I now hit Control C, you can see it just ends, it terminates, it interrupts what's going on, it goes to the next line. We can mess with this. So we can do stty, if you want to play a prank on somebody, you can set this to the O key. So now if we start typing echo, oh look, when I got to the O, it echoed that O, but then it interrupted and went to the next line. And so I can't actually type the O. The O is now that. I'm actually gonna open up a new terminal because I think that one is probably in bad shape. Now I could probably set it back, but I don't remember how to put in that command. So that's some of the stuff that's coming out of stty and these settings, right? I guess I could have shown, this, if I had run stty minus a on that previous one, you would have seen O here instead of, caret C. So that gets to, there's a couple shortcuts that are used. We can actually, again, we'll go back into the stty man page. There's this idea of raw mode and cooked mode. Oops, I'm somehow off screen. Let's get up here a little bit. If we search for raw, raw, here we go. So this is just shorthand for all of this stuff, not, nodding most of these things. And you have cooked, I'm guessing it's right. What did it get? Oh, let's see. Cooked, where does that show up? Same as cooked. Where are you, cooked? Here you go. So it's the same as turning on all those same things. And so not cooked is the same as raw. Makes sense. And so we're going to need to know those as well. We'll kind of get back to, in general, what you think of as raw and cooked is. Raw is, I don't want to handle a lot of the stuff, right? I don't want to handle that control C. I want to just send everything through. I'm kind of backing off and letting the process that's running take control. Why would I want to do that? Great example, I always run tmux. And so if I open up tmux, now if we look at, actually, let's exit for a second. If I do TTY, we can see I'm in 3. If I do tmux, we can see I'm in TTY 0. If we do, let's see, is it, so if we do stty minus a, you can see, I don't know if you noticed, but we went from 30 rows down to 29. That's actually because the tmux banner is taking up 1 row at the bottom, so tmux is telling it that. We've actually opened up a new TTY in here. Well, we're still running in the context of that old one, and what we actually want here is the old one to just be passing everything through, because tmux is going to manage that. So we have this bash session, but we don't want it to process that stuff. We just want to send it all in. A similar example would be like, let's just say you open Vim or Nano. When you put in the up arrow key, you don't want the terminal catching that and going to your previous commands. You want to let that through so that Vim or Nano can move the cursor up and down like it does. We can do, let's see, I always forget, let's see, man, stty. We can specify a device with capital F. Quit this. So if we do stty minus a dash f, I think it was dev pts 3 was our outside one. And you can see now that all of this stuff got turned off. So we're no longer echoing. We're no longer, there's a bunch of things, and we could go to the man page, but all these things are now in raw mode because when I start tmux, it turns its current session, the originating TTY into raw, and then it passes all this stuff through so that, its new PTY can handle it. Hope that makes sense. So with that, how do we get a PTY, a TTY? There's a bunch of ways, right? So, for one, I can come up here, when I click this little icon right here, it is a shortcut to the mate terminal. And it actually runs mate terminal. So I'm not running bash here, I'm running the mate terminal, and then mate terminal is opening up bash or my shell of choice. And so that happens within a PTY, TTY. Similarly, we can do, man SSH. If we look at SSH, let's see, terminal. Yeah, so, to say you've got let's go down here. If an interactive session is requested SSH by default, it'll only request a PTY when the client has. Okay, so basically what happens is if you SSH into a box, it requests a PTY for you. If you look at the very top of SSH, it might be easier to exit and just come back in. When you run SSH, you put all these options, then you have to have a destination. And after the destination, you have an option to put a command. So you could put like SSH, some host ID, and it would just print out ID. So what we see here in the man page is it actually creates a PTY if you run with no command, but if you give it a command, it does not create a PTY. And that's why you actually have the -T and -T switches, where you can explicitly say, I want a PTY here, give me a PTY, or don't give me a PTY, I never want a pseudo terminal. So, but in general, SSH gets you one. And that's why when you get a SSH creds on a box and you SSH into it, you don't have to worry about any of this shell upgrade stuff. It just happens, right? You've already got a PTY, you're working that naturally. So there's a couple other cool ways to do this. We got script is the trick I typically use nowadays a lot. If we man script, this is going to make a type script of the terminal session. So it's a way of logging your session, right? But we'll notice if we do, so the command I typically do is script dev null -c bash. So what is this saying? I'm going to save a script. I'm actually going to save it to dev null because I don't care about it. I want to throw it away. And I'm going to run the command bash in that script. And when I do that, you can, before I do, I'll show we're in dev pts 0. Now in this new one, if we do TTY, you can see we're in dev pts 4. So we've actually, what script does is it starts a new TTY session, regardless of how you run it, and it then works within that. So if we're in a place where we don't have a TTY, by running script, we are now running within one. So that's super useful. I can exit out of that. Another one that is very common is you might see like Python 3 -c, -c import pty.spawn bash. And here, all I'm doing is I'm using the Python pseudo-terminal library to spawn bash within its own pseudo-terminal. So again, we'll see this, and if we do that, when we run TTY, we're back in 4 again. Now, as soon as I exited here, this one went away and was back to being available to use, so I'm now back in 4 again. So these are all different ways where I can get myself running in the context of a TTY. So with all that background, we're now going to walk through some diagrams here to talk about what's really happening under the hood with the reverse shell. So we'll start off here. I've got a fresh reverse shell on my target. You can see here that I've got running through a TTY netcat on my own session, connected over to a bash reverse shell on this target box. And so let's just say we run like the ID command. And so the string ID is sent through the tunnel, hits bash, starts an ID process, some results come out, boom, they come back, they hit my terminal and they display. That all looks great. Okay. So now let's just say I run some really long running command. I don't know why I would actually ever type sleep for an hour in here, but let's just, I put something in here that's going to run for a long time. It's going to get stuck. And I'm sitting here going, man, I don't really want to wait for this to finish. I want to kill it. And so I'm going to enter a control C, and that control C is going to come down here and it's going to get picked up at my session. And this is where my TTY is going to catch that. It's going to kill the netcat. It kills the bash on the other side because that reverse shell ends. So I'm back here at my prompt on my VM, oxdf at hacky. And not only that, but I've left this long running process running on the target, which is not really where I want it. It's not very OPSEC friendly if I'm trying to hack something. So none of this is really where we want to be, right? So let's go back fresh here, and we're going to actually upgrade this shell. So we're going to start off. We're going to get a TTY. We're going to do it. In this case, we'll use script. And so that goes through the tunnel, hits the bash, and is run. And so now I've got bash running script, which then has a TTY wrapped around bash. I have a kind of a question mark in there. On my side, the TTY is in cooked mode. We talked about that earlier. I've got a question mark for exactly the mode it's in. It's not in like a particularly clean state, but it certainly works. It's there. Next, we're going to control Z, and we're going to background this, because now this is the part where we got to really manage to get our side kind of turned off, if you will, or put into raw mode. So when I control Z this, you can see I've got my netcat has now dropped into the background. I kind of showed as gray. It's still connected, but it's just not running. I've got this bash running here on my side, right? So I'm going to do the stty raw -echo foreground. And so when that goes down, it's going to hit my side still. The first part, the stty raw -echo, takes me out of cooked mode and puts me into raw -echo. And then the foreground is going to say, oh, hey, that netcat was in the background. Let's bring it to the foreground. It's now running again. And then that's where it prints out the command line. And that's what shows up in the terminal. So technically now here we are connected. We're in the state we want to be, except the terminal, the TTY on the remote side is still in kind of a funky state. And so this is where we're going to issue the reset command. And so, the reset command, this is straight off the man page, but it's going to set it to cooked and echo modes. It's going to turn off cbreak and raw modes. Does some stuff here. Sets all the unset special characters back to their default values. It basically gives me a clean terminal. And so we're going to run that. It's going to go through the pipe here. And rather than showing all this back and forth in little diagrams, I pulled up this Wireshark capture here. There's a couple things to notice. First, it's kind of neat to see. So I hit the R on my side, right? And that's that kind of reddish brown R. it then immediately goes through the tunnel, hits the remote process. The remote process processes that R, echoes it back, because now we're running in a TTY with echo. So that echoed R comes back, and that's what displays. So the first R, the reddish R, doesn't actually show up in my terminal because I'm not in echo mode. But that output, that when it comes back, that R is what shows up in my terminal. And so it actually happens fast enough that you can see the R comes back before I have a chance to hit the E, etc. The same thing happens when I'm typing out screen. So then after I run reset and send it. Then the reset comes back, complains about my terminal type, and give it the terminal screen. Then there's some funky looking characters here, and we're going to zoom in on that, right? Here, this is the same stream, just viewed as a hex dump. So you can see I send the E, then comes back their E. I send the N, then comes back their N. I send an OD, which is a new line. They send back new line carriage return, and then hits all of these next string of characters. And so these are ANSI control sequences. And anytime you see 1B, you're going to want to think about that's the start of an ANSI control sequence. And the important one here, 1B63, which is 1B C, is the reset control sequence. And so you can actually try this in a terminal if you type echo space -E, and then your string is \x 1B for that 1B character, and then C, and then print that. You'll actually notice your terminal resets, and that's kind of cool. The rest of this stuff is not super important, but it just comes along with the reset command. After that, you've got a new line, and then in comes dub data at target. It's just the prompt. And so what I end up with here is a nice clean prompt and a terminal that is now expecting how I want it to, performing the way I want it to, such that when I send things like up arrows and control C's, they're not going to get processed at my TTY because I'm in raw mode. I'm going to type things, those aren't going to come out from my, because of the raw mode here, but because of the cooked mode on the remote, those things will be handled, echoed back, etc., and it'll behave just like I have a terminal on that system. All right, so we're going to jump back into the terminal here and apply some of this. So we'll do a netcat -lvmp 443, and I've got a target here where I can just run, basically anything. So if I run ID, it prints out ID here from the remote, remote target. Host is not a command, right? Host name, see it's target. So we will go ahead and get a bash reverse shell -I. If you're interested in the details of how this one works, I've got a video on this as well. It's a good one, if I don't say so myself. 10, 10, 14, 6, 4, 4, 3, 0 into 1. And that should work. And we got a shell. Okay, so let's go to, let's just go to here. And so now, reverse shell, got one. Okay, so what are we gonna do with it? We can start off with, we can look and see what happens if I run TTY. We're not in a TTY. That's what we expected, right? So what happens if I hit Control C? Well, as we talked about in the diagrams, like I just killed the netcat process on my local box, and so that's died there. So we'll come up here and we will rerun and get a new shell, just to make the prompt cleaner. We can't clear yet, but we can go down a little bit. Okay, so again, we'll talk about what if we're going to need a TTY. We want to start a TTY, so we'll do script dev null -c bash, and when we run that, now we see that we are, we started script. If we run TTY now, we'll see that we're actually in dev PTS 0, so that's, we've got a TTY now. So we'll background this now, and now we put it in the background. We're back to interacting with my local system, and so this is where we do stty raw -echo. So again, raw here is allowing the control characters and things like that to go right through it and into the netcat pipe, which then eventually hits the bash on the remote system. -echo says I don't want to repeat. I don't want to echo back things as I type them. And I almost always show foreground right here. I'm going to leave it right now just so you can see. So now I've done that. I put this terminal into this mode. If I type FG right now, you don't see it. And the reason you don't see it is because there's no echoing going on. There's no process receiving that. Bash isn't going to spit it back at me and the terminal's not, the TTY is not echoing it. But I can hit enter here, and now that netcat process is brought back to the front. And so now when the netcat process is running and receiving my standard in, the terminal's kind of jacked up, so we do our reset. Now it's, again, as I mentioned in the previous part, when I hit R, my terminal, my TTY is not printing the R to the screen. That R is going through netcat, hitting the remote system, and then coming back and then printing out as a result there. So when I hit reset, unknowns, we'll do screen, and that control character came through, and here we are back with a fresh terminal. This terminal works, so we can do things like if we do a sleep 60, and now if I control Z that, it kills it again because my terminal doesn't care about the control C. It passes through, it gets the bash, kills that sleep there, works great. We can do things like cd, let's see, var b, and I can use the tab character, and the tab character again passes through the tunnel, hits the remote system, and runs there. That's exactly what I want it to do. So, I think that's basically it. I can do up and down arrows, also nice to have, very handy when you're typing a lot. So, I think that's about it. In this video, we covered the shell upgrades. We went through some of the what is a TTY? Why do I care about it? How do I get one? What's actually happening underneath the hood when I run all these commands after I get stty raw echo, etc. So hopefully this was educational for you. I know I learned a ton researching for this video, and so I feel like this thing that I've run on every more than once many times a week for the last several years, now I understand exactly what it's doing, and that's cool. So let me know if you want more videos like this, and thanks for sticking around to the end, and I'll talk to you next time.